Hey Mauricio, this is Simon, and I've created this video for you just to show you how to go over questions type 3 and 4. I know that you sent me a message on WhatsApp. You said that you completed question type 1 and 2 in the practice questions I gave you, but you're stuck on question type 3. So I did not give you practice questions for question type 4. So I thought what I'll do is I'll give you an explanation and give you this video to show you how to go over questions types 3 and 4, and hopefully that helps you. If you do have any questions about 1 and 2, let me know as well, but you seem confident with that. I didn't check your answers because I know you sent me that as well, but I know that you do feel confident with that. I've seen you do it before and you did know how to do this, so hopefully this is really just a refresher for you. And I also know we did do videos on your laptop, but they were really cut up, really poorly done. I don't know why it happened the way it did, but hopefully this video will be a lot more coherent. So let's get into it. If you do have any questions, let me know, but we're just going to start right with question type 3, and I'm going to use the same example that you have for your eLearn practice tests. It's the same thing. It says, given the following network address and conditions, calculate the information listed below the second available subnet. The network address is 128.1.2.3, and it says you need 68 hosts with as many subnets as possible. So this question is really similar to question type 2. In question type 2, it says the same thing. The only difference is it tells you you need 37 subnets. So in that question, you needed to prioritize how many subnet bits you got first, and whatever was left over would be your host bits. In this question, you're going to be figuring out your host bits first because we need 68 hosts. So we're going to figure out the host bits first, and then whatever is left over will be your subnet bits. And the only other difference with this is once you figure out the host bits, you have to make sure that they go at the very end of your IP address, because that's where the host bits go. If you remember the flag, I kind of gave you like the Canadian flag, and I said on the left side you have your network bits, in the middle you have your subnet bits, and then on the right side of the flag you have your host bits. It's kind of like that. Well, it is like that actually. So when you have your host bits, you're going to put them down, but you're going to put them at the very right of the IP address. And then anything that's left over on the left will end up being your subnet bits and your network bits. So if that sounds really confusing, don't worry about it. I'm going to show you what I mean. But let's get into it. The very first thing that you always have to do is write down the default subnet mask of the network address that you're given. So it starts with 128. We know that that means it's class B. And the default subnet mask is 255.255.0.0. And what that really essentially is showing you is what network bits are and what host bits are. So we have 16 network bits because 2 octets have 255. So 1, 2, 3, 4, 5, 6, 7, 8. Point 1, 2, 3, 4, 5, 6, 7, 8. Point, and then the host bits are your zeros. So there's 16 there as well. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's great, but that's not subnetted yet. We haven't put our subnet bits in there. And remember that we're borrowing from the host bits. So the network bits are going to stay the exact same. So what I can do is technically just copy and paste that down here. Okay. There we go. But the host bits are going to change because we don't need all 16 host bits probably. But how do we figure that out? Well, like we said, we have to figure out the host bits first and figure out how many host bits do we actually need. So right here it says 68 hosts. Now remember, think of your 8-bit octet. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Think about what each of them represent. This one right here represents 128. This one is 64. This one's 32. This one's 16. This one's 8. This one's 4. This one's 2. And this one's 1. Right? Makes sense? You will notice that none of these represent 68. So that's okay. We don't care that it represents 68. We just need a number that can satisfy that. And we want the first number that satisfies it. So even though, maybe let's pretend that this number was 4. If it was 4, there is one that's 4. But you could go with 64. You could go with 128, but you don't need that. Remember, it says you need 68 hosts with as many subnets as possible. So we're really just looking for the first number that satisfies that rule. Remember too with 4, when we're looking at host, another rule that's really different than finding the subnets is you always take away 2 from the total hosts. So if I gave you an example of we needed 4 hosts, and I said to you, well, we have a 4 right here, remember you can't use that 4, because once you take away 2 from this 4, it becomes 2, and now we haven't satisfied the 4. So it would actually end up being 8. So you have to remember that, but it's only for the hosts. So write that in there for you right there. So always take away 2 from the total hosts, but only when you're finding the host, not subnets, okay, or subnet bits. So that's really important. It's easy to confuse, but if you can get that rule down, that will be really, really helpful. Always take away 2 from the total hosts. When it comes to subnets, it doesn't matter. Subnet bits, feel free to, if it says 64, you can use 64. If it was 64 hosts, you actually need 128 because 64 would end up being 62 really. So I hope that makes sense, but let's move on. If you have questions, ask me later, but I think I've explained this to you, so I think you will grasp that. So we have 68 hosts though. So even if I said 64, 64 isn't going to satisfy 68. So the next number up from 64 is 128. And even if we take away 2 from 128, that's 126. That's still going to be enough to satisfy 68 hosts. So how many bits do I really need? This is where a lot of students get confused because they look at this 128 and they think, oh, this is the 8th bit. So it's 2 to the power of 8, which means that, that's what I need. But if you actually look at it, 2 to the power of 8 is 256. So you got to be careful. Remember that 2 to the power of 1 is not 1. 2 to the power of 0 is 1. 2 to the power of 2 to the power of 1 is 2. So the 128 is actually 2 to the power of 7. So 2 to the power of 7 equals 128. All right? And of course, we'll take away the 2 just for good measure. So the 7 is actually how many bits we're going to use for our host bits. So that is really, really important. So maybe I'll explain it just very quickly again. Basically, when you're looking for your host bits, you look at the number that you needed. So in this case, it was 68. You say, okay, what's the first number that will satisfy it? We saw 64 doesn't, so the next number was 128. And when we took away the 2, they gave us 126, so that satisfied that. And then we said, okay, well, 2 to the power of what gives us 128? And we determined it was 7. And we remember that 1 isn't really where you start with 2 to the power of 1. 2 to the power of 0 is 1. 2 to the power of 1 is 2 over here. And it goes on. So that's why we get 7. And it ends up being 128, even though it's the 8th bit here. So hopefully that's not too confusing. But that's how we got this. So we need 7 host bits. And remember, we had 16. So now we've gone from 16 to only needing 7. So if we have, if we need 7 host bits, all we have to do is say 16, which is what we originally had, and take away 7, because that's what we need. I'll write that down. What we had, what we need, and that's going to leave us with 9. And that's going to be our subnet bits. Okay? So now what we're going to do is up here, we're going to put them in. And it doesn't matter how you do it, because on a computer, it's a little bit easier for me to write down. But when I'm writing it down myself with pen and paper, I usually do it like this. I usually say 1, 2, 3, 4, 5, 6, 7, and then I put in my subnet bits right after the network bits to make up for whatever's left over. So we know that there's 9 left over, so I'll say subnet, 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 dot subnet. And that's it. That's how we figure that out. And of course, like you already know, when it comes to the subnet mask, we just have to change the H's to zeros and everything else to ones. So let's do that. 7 zeros. All right, so when we add all those together and we convert that from binary to decimal, we get 255.255.128. So we know when it's all ones, that's 255. So there's 3 octets with all ones, and then this octet only had a 1 in the 8th decimal spot, or sorry, the 8th binary spot or bit spot, which is 128. That's this guy right here. So that one was really easy. So now that we figured that out, what we need to do is we basically have to figure out the subnet address. Alright? But we can't just figure it out just yet, because what we have to do is look for the second available subnet. So we have to figure that out next. Okay? So I'm going to erase all of this. I'll keep this guy up here just so you can kind of remember this. But when it comes to finding the second available subnet, remember what you have to do. You have to take all of the subnet bits and you have to write them down as all zeros. And that's going to be your first subnet. So I'm going to write that down. 1, 2, 3, 4, 5, 6, 7, 8.0. Do this just because it'll make it easier. A lot of times people forget to put the point, and when they forget to put the point in there, or the period, or the decimal, or whatever, it ends up confusing them. But in this case, it's the second, so this is really, really easy, because we're just going to count up in binary, which you already know how to do, and there we go. That's the second subnet that we needed. If we needed to go further, we could have gone here, and we could have gone here, and then we could have done this, and so on and so forth. But we only need the second subnet. So what you're going to do is you're now going to put that in. Now I'm not going to touch these network bits because we know they're going to end up being the exact same as this, the 128.1. So don't even worry about those. But we are going to put this guy, and I'll even copy and paste it just to show you, right here. Alright? And we know when it comes to a subnet address, the hosts have to be all zeros. So we're going to put the zeros in. 1, 2, 3, 4, 5, 6, 7. Alright. So now all you have to do is convert that into binary. Or sorry, convert the binary into decimal. And that should be really, really easy. Because, in this case anyway, because subnet address, that's what we want. Like we said, the first 2 octets are your network address, or your network bits, so they stay the exact same. So it's 128.1. Then we'll look at this guy, and we see it's all zeros, so we're just going to leave it as 0. And then we are going to look at this guy, and we see it is a 1 right here. So that's the exact same thing as what it was up here, 128. So it's going to be 128. Pretty easy, right? Yeah, so let's move on to the next part, the first usable host. This one you should know because you're very good at this one. First usable host address is just adding 1 to the subnet address. So we have 128.1.0.129. Then the last usable host address. Well, we can't figure that out until we know the broadcast address. And all this should be very familiar to you. Now all you have to do is take this number that you had, but change the host bits to 1s. So you take all of the host bits, these guys, there's 7 of them, right? And we're going to change all of these guys to 1s. 1, 2, 3, 4, 5, 6, 7. So now convert that binary into decimal. You're still going to get 128.1 because those are the network bits, they stay the same. We still have all zeros in that third octet, so that's a 0. And then the final octet is all 1s. So that should be easy. It's 255. Then we can do the last usable host address. And that's just subtracting 1 from the broadcast address. So it's 128.1.0.254. And remember how this works. If you're ever doubting, like, when do I add and when do I not, remember it basically goes subnet address, okay? You can't use that, all right? Then all these guys here are going to be usable host address. And then your final address is going to be your broadcast address. Okay, so what happens is you have one address right here, then you have all the usable host address or addresses, and then finally you have one final address right here, which is your broadcast address. So when you say your subnet address is this guy right here, 128.1.0.128, the next address is just moving up one, right? And then when it comes to the broadcast address, that's your last one. So the last usable host address is subtracting one. You're going this way. So that's why we do what we do, just in case you forgot. Now, this part's easy because you've done this in the second and the first one. First type of question, it's the number of usable subnets. Technically, you already figured this out. We said it was 2 to the power of, and if you want, just count them. There's 8 here, and there's 1 here. So that's 9. So 9 equals, and just remember, it's 512, but you don't have to subtract 2 in this case because it's just subnets. Number of usable hosts, well, we figured this one out too. There's 7 of them. So we're going to say 2 to the power of 7, but we're going to take away 2. So it was 128, but we're taking away 2, which equals 126. And that's it. That's how you do the third type of question. So hopefully it's not too bad. I know that I probably explained more than you needed, but hopefully you understand how to do this. So I will move on to the very next question. So the next question is when you have the map. And like I said to you before, it looks more complicated because there's more questions, but it's really not. It's really basically just doing the same thing that you did here. The only difference is that it's trying to say, pick a network, essentially. Or it picks a network for you, but it's just trying to give you this visual representation of what you did in the previous questions. So it says fill in the blanks using your solution for the drawing above. It gives us all these networks. And like you know, because you answered this question before with me, each of these networks are going to be a subnet. So when it says number of subnets required, you just count them. 1, 2, 3, 4, 5, 6, 7. So that's pretty easy. Number of subnets required, 7. You counted them, it's as easy as that. There's no math to it other than just counting or adding up everything that says network and a letter. Then it says number of subnet bits. Well, in this case we have 7. And we're going to look at all of our bits here. And we're going to say, well, which one is going to satisfy 7? So 1 doesn't, 2 doesn't, 4 doesn't, 8 does. And we're talking about subnets, so we don't have to take away 2. So in this case, 8 actually does satisfy 7. But what's the amount of bits that we're actually going to use? We have to say 2 to the power of something, I'm just going to put x for now, has got to equal 8. And we know that is 2 to the power of 3. So that is how many bits we're going to use for subnets. So when it says number of subnet bits, 3. So number of host bits. Well, this is where we're going to have to figure out how many bits are left over. So let's look at this address. It's 197. The class of it, actually I'll put it above. The class of it is class C. And that means that our default subnet mask is 255.255.255.0. So all the network bits, I can write these down, are in the first 3 octets. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we only have 8 bits for the host bits. That's it. So if we have 3 bits that are going to be subnet bits. That means we're changing these 3 right here. 1, 2, 3. Because remember, the subnet bits come after the network bits, and they come before the host bits. So what does that leave us with? Well, it's easy math, so in this case, it's 5. So there we go. Now, the next question actually says default subnet mask. You kind of have to do that before you figure out the number of host bits anyway, but I guess they put it there. I don't know. Maybe to trick you. I really don't know. But now we have the subnet mask that we have to figure out. Well, that's pretty easy because all you're going to do is just change the host bits to zeros and everything else to ones. So we're going to say 1, 1, 1, 1, 1, 1. 3. There we go. And we're just going to convert that binary into decimal. So all of these are 255s, obviously, and then we're left with these 3. And I know that it's 224. You will get really, really good at it, but basically all you're going to end up doing is just saying 128 plus 64 is going to equal 192, and then you're going to say 192 plus 32 equals 224, and that's how you got your answer. Alright, so you finished the first section, and that took no time at all. So we have to move on to the next section, and it says for network C, figure out all this stuff. Now, it doesn't tell you this, but basically what it wants you to do is assume that network A is your first subnet, network B is your second subnet, network C is your third, network D is your fourth, network E is your fifth, network F is your sixth, and network G is your seventh. So, again, they don't tell you that, but you just have to kind of put that together. So if we're dealing with network C, we're really dealing with the third network. So when we're dealing with the third network, what we have to do is what we did basically up here, right? But you have to make sure that you're only putting in your subnet bits because that's the only thing that really matters. In this case, we only have 3. So what we're going to do is say 000, and that's the first subnet, network A. 001, that's your second subnet, network B. 010, not 2, 010, third subnet, network C. So that's good. That's good enough because that's all we need is we need network C here. So we're dealing with this guy. And once again, you should know that when it comes to the network bits, they're never going to change. We're going to keep the first 3 octets because those are our network bits. So 197.2.3 is going to stay normal. So we're really going to have to just implement this here. So let's change these 111s because those are our subnet bits to this guy, which is 010. Now that we've done that, now all we have to do is just convert it from binary to decimal. So what we have is subnet address. Remember, the host bits are going to remain 0 because when we're looking for subnet address, there's zeros. And we're going to keep the network bits the same. So it's going to be the same 197.2.3. It's only the last octet that's going to change. And it's only a 1 right here, which represents this guy, 64. So this one was really, really easy. Now, first usable, we're just adding 1. So 64, add 1 is 65. Last usable, we can't figure out yet because we need the broadcast address. And in this case, all we're going to do is we're going to highlight all those host bits. So there's 5 of them. So 1, 2, 3, 4, 5. There we go. And change those zeros to all ones. It's the opposite, right? 1, 2, 3, 4, 5. And now we're going to convert this whole thing from binary to decimal. Leave the network bits as the decimal numbers that we've had before, the 197.2.3, and that's going to be our broadcast address. So you can put all this in. So you're going to say 1 plus 2 plus 4 plus 8 plus 16, and then you're going to say plus 64. You can figure that out on your own. The way that I do it is I know that if all of these are 1s and then this is a 0, that means that all these equal 31 because they will equal the number before this number. So I'm just going to say that just to make it very easy on myself. I'm going to say 31 plus, because remember we still have this one here, and this one equals 64. So we'll say that, and that's going to give us 95. And I just figured that out. It's 4 plus 1, which is 5, 6 plus 3, which is 9. It's a simple calculation, and I'm not great at math, so I'm sure that you already figured that out. So it's 197.2395. And the last usable was 197.2.3, and we're just subtracting 1 from the 95, so it gives us 94. And we're almost done. This part we've already kind of answered. Number of usable subnets. Remember, we figured this out above here, right? When we said how many subnet bits are we going to have? Well, we said that we need 3 because to satisfy 7, we need a total of 8. So what we're going to do is we're going to just put that in. 2 to the power of, we had 3 subnet bits equals 8. And the number of usable hosts. In this case, we said 2 to the power of 5. But remember, we have to subtract 2. So that's really going to end up being 32. Take away 2, which is 30. And that's it. So it's really, really easy, in my opinion. It's not really complicated. You just have to do it several times. Once you do it, it almost becomes muscle memory. You will find that it gets easier. Like I said, in 4th term, you'll actually find a really easy method to figure out the addresses and the ranges of Class C addresses. So I'll show you that once you've done your test, but this is really how you figure out question type 3 and 4. Hopefully this made sense. Like I said, if you have any questions, let me know. But like I said, I've kind of explained this to you for weeks now, and I showed you last weekend how to do this. So I think that you're really looking for a refresher, so I'm probably went into more detail than you want. But by all means, any questions you have, let me know, and I'd be happy to help. Take it easy, and I will see you tomorrow. Bye.